Okay, so today we're going through the length of a curve. You might also see it as arc length. Okay, so if you're looking online for YouTube videos and stuff, you can look for length of a curve. The videos might also have it as arc length. Okay, it means the same thing. Okay, so length of a curve. Okay, you might also see arc length. Okay, we will only be looking at the 2D case. Okay, so curves just with x and y. Okay, there is a formula for 3D case, x, y, and z. Okay, it's not too different from what we're going to be doing, but that won't be tested. Okay, so it will only be the case with x and y. Okay, but if you're looking at YouTube videos, they might have x, y, and z. You can just ignore that z part. Okay, so let's go through how we get the formula for the arc length. So we looked at this a little bit before, but we'll go through it again. So let's say we have some sort of parametric curve. Okay, some x of t, y of t, and that gives us this curve here. What we do is at every point, we draw a little triangle like that, where the hypotenuse goes along the curve. So this hypotenuse we call ds. So S is usually used for the length of the curve. S or L, you'll see that. That horizontal distance, that's going to be dx as usual. And the vertical distance, that's going to be dy. Okay, so that little bit of length along the curve, that hypotenuse we call ds. Now this is a right angle triangle, so we can use Pythag with this. So ds squared will be dx squared plus dy squared. Right, that's just Pythag. Now, x and y are both functions of t, so we can substitute for the differential. So now we have ds squared is going to be x dot squared dt squared plus y dot squared dt squared. Right, because dx is dx by dt, and then we just write that as x dot. And dy is dy by dt, and we put that as the y dot. Now the first term and the second term both have dt squared, so we can factor that out. So it will be ds squared is equal to x dot squared plus y dot squared dt squared. Okay, now we've got squares on both sides. We want to get rid of that. So we take the root of the left-hand side and the right-hand side. So we just get ds now, and that's going to be the root of x dot squared plus y dot squared dt. Okay. Now ds, that's the little bit of length. We want the total length, so we integrate both sides. So s, that's the total length, is the integral of ds. But if you integrate that side, we just integrate the other side. So that's the integral of that. Now you might also see this as L. Okay, so the length of the curve, you either call it S or you call it L. That doesn't really matter. But in the textbook, it's S. Okay, so L for the length of the curve, or S, this is the integral from a to b, square root of x dot squared plus y dot squared dt. A and b, those are the parameters, right? So the t parameter, so we start at a and we end at b. So a less than or equal to t, less than or equal to b. Okay. So the way to think of this is like a particle moving along a curve, like we did last week. So if we've got some curve like this, so that's the motion of the particle. So let's say the particle starts over here at t equals a. It moves along the curve to here at t equals b. Okay, so the length of the curve you can think of as the distance that particle would travel. Okay, so we imagine a particle. Okay, so this goes back to that physics view that we looked at last week. So we imagine a particle moving along a curve. curve. Okay, so this S is the distance covered by the particle in that delta t time. Okay. So you might see questions like this. So you've got a particle moving along some curve. What is the distance covered by the particle? Okay, so that's like the physics view of this length of a curve. Okay, and we can see that a bit more easily here. So let's write this out again. So we have a to b root x dot squared plus y dot squared dt. Remember, x dot, that was the speed in the x direction. Y dot, that's the speed in the y direction. So the root of x dot squared plus y dot squared, that's just the length of the velocity vector. Right? So if you have the velocity v, that's x dot in the r direction, y dot in the j direction. Okay, you know you got your speed in the two directions. Then your speed, or the length of the velocity vector, okay, that's just the root of x dot squared plus y dot squared. Right, that's just the length of the vector, so that's the speed of the particle. So here, if we look at this equation again, this x dot squared, y dot squared, that's just your speed v. Okay, without the vector, so it's just your speed times dt. Okay, but speed multiplied by time, that's distance. And the integral is just adding up the distance. Okay, so you can think of it like that. So again, this root x dot squared plus y dot squared, that you can think of that as the speed of the particle multiplied by dt. That's the little bit of distance covered. Speed times time is distance. And then you're just adding it all up. Yeah. So again, this is the physics view of a particle moving. Okay, so this is your speed. Again, root of x dot squared plus y dot squared, that's the speed, multiplied by time, and that gives you the distance. Okay. Okay, but that's just the physics interpretation of what's going on. All of the questions we're going to be looking at is just find the length of the curve. Okay, so you don't need to understand this physics view, but you will see that later on. Okay, I think next year when you do more mechanics, it will be more like this. Okay, examples. Let's have a look. So number one, we've got the following curve. So x is given by 2t and y is given by t squared. Okay, so that's our parametric curve. You don't need to worry about sketching any of these. It's just given in parametric form. What we want is the length of the curve from t equals 0 to t equals 1. So that little segment, what is the length of that? Okay, so we just go through the steps. So remember what the formula was over here. So we need to find x dot and then square it. We need to find y dot, square it, and then do this integral. So we're given x and y. Now we need to find x dot and y dot. So x dot, that's just going to be 2. Very easy. Y dot, that's going to be 2t. Okay, so that's the derivatives done. Now we can just substitute this into the formula, do the integral, and that gives us our length. So s is equal to the integral from 0 to 1, since the t values go from 0 to 1. Okay, root of x dot squared plus y dot squared dt. So this will be integral from 0 to 1, square root. X dot squared, that's just going to be 2 squared, so that will be 4. Plus y dot squared, well, that's just 2t squared, 2t, all of that squared, so 4t squared dt. Okay, 4 is a common factor for both. We can take it out of the roots. That will just become a 2 on the outside. So that will be 2 integral from 0 to 1 root of 1 plus t squared dt. Okay, now we've got root of 1 plus something squared. We want to integrate that. Okay, trig substitution. In this case, it's a squared plus t squared, so that will be a tan substitution. So t will be tan theta. Okay, so there's nothing in front of the t. The a is just 1, so t is just tan theta. Now we need dt, so dt, dt, that's going to be sec squared theta d theta. Okay, what about the bounds? Okay, this is a definite integral, so we need to change the bounds. So when t is 0, theta is going to be 0. So t being 0, that just means theta is 0. And then the upper bound, t is 1. If t is 1, theta must be pi over 4. Okay, so we've got our theta bounds there from 0 to pi over 4. Okay, now we just substitute. So this will be 2 integral from 0 to pi over 4 now because of the bounds changing. Then we have the root of 1 plus tan squared theta. And then the dt, that's going to be the sec squared theta. So 2 integral from 0 to pi over 4. Now we can do some simplifying. 1 plus tan squared, that's sec squared. Take the root, that's going to be sec. Sec times sec squared, that is sec cubed. Okay, we've done this one before, with the integration by parts. So I'll just put the answer down. So this will be 2. Then we have 1/2 sec tan plus 1/2, and then the natural log of sec theta tan theta. Okay, if you forgot how we got to there, just go back to the integration by parts notes. I'm not sure which lecture it was, but we covered the integral of sec cubed with integration by parts. Okay, now it's just a matter of substituting. So pi over 4, tan of pi over 4 is just going to be 1, so we can just put 1s there. And then sec of pi over 4, that's just going to be root 2. Right, because cos of pi over 4 is 1 over root 2, so sec of pi over 4 is just root 2. So this will be 2. Oh, we don't need the 2. The 2 can go inside to cancel the halves. So this will be root 2 plus the natural log of, again, sec theta, that will be root 2, and tan theta, that's just going to be 1. Now, if we substitute 0, tan of 0 is 0, and then for the log, we get log of 1, that's also 0, so that doesn't add anything. Yeah, so we end up with root 2 plus the natural log of root 2 plus 1. Okay, any questions on the first example? Okay, all of them are pretty much exactly the same. You're given x and y. You need to find x dot and y dot, substitute, and then just treat it like a normal integral. Okay, with whatever technique you need. Okay, number 2. Here we have x is sine squared theta, sine squared t, and y is cos squared t. And this is going to go from t being 0 to t being pi. Okay, so these three will always be given to you. So you'll be given x, you'll be given y. Remember, we don't do the 3D case with z, so you can leave that out. And you're given the bounds for t. Okay, step 1, x dot and y dot. So x dot, okay, a little bit of chain rule. So this will be 2 sine t cos t. Y dot, this will be 2 cos t sine t. And then we get the minus from the derivative of cos. Okay, then once we've got that, substitute and then just solve the integral. So s, that will be the integral from 0 to pi. Then we've got the square root of x dot squared. So that will be 4 sine squared cos squared. Okay, plus, and then y dot squared, that will be 4. And again, sine squared, cos squared. So there will be just 2 copies of that. dt. Okay, but this is just adding them together, so we get 8. 8's a constant, we can take it out. So we end up with root 8 on the outside. You can simplify that to 2 root 2 if you want. Okay, so that's the integral from 0 to pi, root of. And then what's left over is just the sine squared, cos squared. Sine squared t, cos squared t, dt. Okay, now here we need to be a bit careful. Okay, so a little bit of warning there. Remember, the root of x squared is the absolute value of x, right? Okay, so if you've got root of x squared, it's the absolute value. So in this case, we need to be a bit careful about what the function looks like on that bounds there. So here, if we just draw this function here, so it will be root of this, so absolute value of sine t cos t. Okay. If we just do a little sketch of that, it's going to look something like this. Right, because the absolute value makes it always positive. So here we have 0, here we have pi over 2, here we have pi. So the absolute value of this is always positive, so it looks something like that. If we didn't put the absolute value, then it's going to look something like this. So it'll just be like your normal sine. So it will be something like this. 0, pi over 2, pi. Okay. Now, integrating these two will be very different if you leave out the absolute value. So with the absolute value, you're going to get this positive amount here. Okay. But if you leave out the absolute value, notice we've got some positive amount here in blue, and then this negative in red. So the total integral for this will be 0. Okay. So it's going to be a very big problem if you leave out the absolute value. If you just write this as, cancelling the root and the square, your integral will end up being 0. Now you can't have the length being 0. That makes no sense. But with the absolute value, you get some positive amount. Okay, so again, please be careful with your roots of x squared. Okay, roots of x squared is not x, it's absolute value of x. Okay, so this will be 2 root 2, integral from 0 to pi, absolute value of sine t cos t dt. Again, I'll just write this on the side here. Root of x squared is absolute value of x. Okay, you've seen that before with that root and the x squared. Okay, now sine t cos t, writing it like this is a little bit difficult to work with, but remember your double angle. So sine of 2t is 2 sine t cos t. So we can write this as 2 root 2 integral from 0 to pi, absolute value of 1/2 sine 2t. Okay, a little bit easier to work with than having the sine and the cos. The half can come out, so we just get root 2 integral from 0 to pi, absolute value sine 2t dt. Okay, and this goes with the first picture over here. Okay, so we're integrating that first one. Now notice we've got 2 parts to it, so from 0 to pi over 2, and then pi over 2 to pi. So what we can do is just go from 0 to pi over 2, and then double the answer. Okay, because from 0 to pi over 2 is the same as pi over 2 to pi. So just do the first part and then double it. So this is going to be double, and then integral from 0 to pi over 2, sine 2t dt. Okay, so you could either do it like that and just double the result, or you could write this as the integral from 0 to pi over 2 of all of that, plus the integral from pi over 2 to pi, like that. Okay, so you go from, the minus sign. So you go from 0 to pi over 2 for the first part, minus, and then pi over 2 to pi for the second part. You split it up into the 2 bits, or you just go from 0 to pi over 2 and then double your answer. Okay, you get the same thing. You can decide what works for you. Okay, so we get 2 root 2. Integral of sine, that's minus cosine. So we have minus 1/2 cos 2t from 0 to pi over 2. Okay, then you just substitute pi over 2 and 0, and we end up with 2 root 2. Yeah. Any questions on this one? Yeah.
Can you explain the concept thing about doing those?
Oh, okay. So I'm just splitting this. So you know the integral from a to c is the same as the integral from a to b plus the integral from b to c. So we do this first part, number 1, and then we do the second part as number 2. Okay, and then you put the minus sign because this bit would be negative here. So we need to flip it up. Okay. Any other questions? No, good. Okay, it's just like the definite integral stuff we looked at last year. You split it up from a to c, and then you have integral from a to b plus the integral from b to c. You can always split it up like that. Any questions? All good. Okay. Number 3. Okay, so here we have x is equal to t squared and y is equal to t cubed. Okay, we want to go from 0 to 2. So starting from 0, ending at 2. Okay, same steps as before. We need x dot and y dot, so we take the derivative. So x dot, that's going to be 2t, and y dot, that's going to be 3t squared. Okay, pretty easy. Then we substitute into that formula. So s or L, whatever you want, is equal to the integral from 0 to 2 square root of x dot squared, so that's 4t squared, plus y dot squared, so that's 9t to the 4. So 9 times t to the 4. Okay, and here we want to do the integral. Now, before you jump to trig substitution and all of that, because you see the square, notice that both terms have a t squared as a common factor. So again, you might see t squared, you want to jump to trig substitution, but try and simplify first. So the first one is a t squared, the second one's got a t squared, we can factor that out. So this is the integral from 0 to 2. Okay, t squared we can take out, so that's just a t in the front. Then we have the root of 4 plus 9t squared. Yeah. And then at this point, it's just a u substitution, right? Like we did a couple months ago. Okay, so if we let u be that inside part, then the du, we can work with that t there, the t dt. So u substitution, where u is 4 plus 9t squared. So du, that will be 18t dt. Now we wanted to get rid of the t dt, so we can take the 18 to the other side. So 1 over 18 du is t dt. Okay, so that takes care of all of that. Then we're just left with u to the half. Okay, that's easy to work with. Now the bounds. So the first bound is t equals 0. So if t is 0, u is going to be just 4. And then the upper one where t is 2, we're going to have 4 plus the 36, so that's going to be 40. So u is 40. Okay, so let's substitute. So we have the integral from 4 to 40. T dt, that's covered by the du. So we just have root of u, which we can write as u to the half. Okay, 1 over 18, that's a constant. We can take that out. So that will be 1 over 18. Integral from 4 to 40, u to the half du. Okay, very easy. It's like day one. Add 1 to the exponent to make it 3 over 2. Divide by that, so that becomes 3 over 2, and then divide 2/3. Okay, u to the 3 over 2 from 4 to 40. Okay, and then it's just substituting in. That's very easy. Okay, 2 over 18, that's a 9 at the bottom, so 1 over 27. Then we've just got 40 to the 3 over 2 minus 4 to the 3 over 2. Okay, you can simplify that. You got your calculators. Okay, any questions on this one? All good. Yeah. Sorry, you substitute which part? No, it's a definite integral. We don't substitute back. Okay, so we end up with this. And now, just please take notes. The first problem we did, that used a trig substitution. The second problem we did, that had a trig integral. And now this one has a u substitution. So you can see with all of these problems, we're using all the techniques that we looked at in the first half of the semester. So, whatever crazy parametric curve that's given, you need to know your u substitution, like with this one, your trig integral, trig substitution, all of that comes back with this. Okay, any questions? All good. Okay, let's look at the next one, number 4. Okay, so here we have x is t minus sine t, and y equals cos t. Okay, so right away we've got some trig functions here, so we should expect some sort of trig integral. Okay, so please remember all of those things. And we want to go from 0 to 2 pi. Okay, so starting from 0 and ending at 2 pi. That will then be the bounds for the integral. Okay, we need x dot and y dot. So x dot, that's going to be 1 minus cos t, and y dot, that will be minus sine t. Okay, we got x dot, y dot. Let's substitute into the formula. So s, that's equal to the integral. The bounds for t are given, 0 to 2 pi. Then we got the big root. X dot squared, so that's 1 minus cos t squared. And y dot squared, that's sine squared. Okay, so we're going to end up with some sort of trig integral here. Okay, 1 minus cos t, all of that squared, we can expand that out. So this will be the integral from 0 to 2 pi, square root 1 minus 2 cos t plus cos squared, and then plus sine squared. Okay, cos squared plus sine squared, immediately we know that's going to be 1. So we end up with 1 plus the 1 from the beginning, so 2 minus 2 cos t. dt. Okay, so we end up with a trig integral. So what can we do from here? So we've got 2 minus 2 cos t. Let's see what we can do with this. So this sort of looks like what we do with sine squared and cos squared to write it in terms of cos. So just on the side, I'll put a little reminder. Remember, if we have sine squared theta, this is going to be 1/2 1 minus cos 2 theta. Right, from before when we did the trig integrals. Now, if we replace theta with theta over 2, we're going to end up with sine squared theta over 2 is 1/2 1 minus cos theta. Okay, we end up with that. Now, for our problem, we've got 2 minus 2 cos t. On the right-hand side, we got a half. We want that to become a 2. So let's multiply both sides by 4. So we got 4 sine squared theta over 2. And then the 4 over 2, that's going to become a 2. And we end up with 2 minus 2 cos theta. Okay, which is what we need for our integral here. Okay, so a little bit of work with the double angle, the sine squared being written in terms of cos. So remember, sine squared, half 1 minus cos 2 theta, cos squared, that's 1/2 1 plus cos 2 theta. Okay, so please remember your trig identities. Okay, so this whole inside part here, we can replace with the 4 sine squared t over 2. So that's the integral from 0 to 2 pi square root of 4 sine squared t over 2 dt. Okay. So very similar to what we had before with the roots of sine squared 2t. Now roots of 4, that's just going to be a 2. We can take that out. So this will be 2 integral 0 to 2 pi. And then the root and the square, that's going to become absolute value. Okay, something like that. Now, we don't want to have to deal with absolute value, so let's do a little sketch on the side to see if we can rewrite this. Okay, so again, we know what the sine t over 2, what that's going to look like. So it's just some sine graph like that. Okay, where it goes some positive parts and then some negative parts. So this is just sine t over 2. Okay, but absolute value sine of t over 2, that negative part is now going to become positive from the absolute value. So it will have that same double hop thing like we had before. So this one is absolute value sine t over 2. Okay. So with the sketch, we can see we can do the same thing as before. We can just integrate that first bit and then double the result. So are we going to do that? So we just double this. So 2 double that, we just write it as 4. Integral from 0 to pi. So we're going to do the first half and then double the answer. Okay, so that's going to be 4. Integral of sine, that's going to be minus cosine. Then we have to divide by the half, so that's the same thing as timesing by 2. So we have minus 2 cos t over 2 from 0 to pi. Okay, and then you just substitute the balance, that's not too difficult. And then the 2, that will make this an 8. Okay. So we end up with just 8 for the length of the curve. Okay, again, please remember your trig identities and all of that stuff from when we did the trig integrals. So the one for sine squared like this, the one for cos squared minus sine squared is cos 2 theta, sine 2 theta is 2 sine theta cos theta. Okay, all of those are important. Okay, for this. Right. Any questions on this one? Yep. Trig substitution. With which one?
So this question. Actually, we would just sign squares.
Yeah.
We have just done trig substitution.
We'll substitution with what though? Because it's not like 1 plus x squared or a squared plus x squared. Yeah, trig substitution only works when you got your squares. So like a squared plus x squared, you do like a tan substitution or something like that. Yeah. But yeah, no, there's always more than one way, so you can try a different way. But yeah, no, trig substitution won't work. Okay, maybe there's something else you can try. Okay. Any other questions? All good. Okay. Number 5. Sorry, let's check. Yeah, number 5. Okay. So here we have x is equal to cos cubed t and y is equal to sine cubed t. And we want to go from 0 to pi over 2. Okay. Again, trig, so please remember all of your trig stuff for this. Okay, let's do x dots and y dots. So x dots, the 3 is going to come down. So 3 cos squared t sine t, and then we need the minus there. And then y dots, that will be 3 sine squared t cos t. Okay, it's a little bit of chain rule for that. Okay, so we've got x dots and y dots. Let's substitute it into that formula. So s, that's the integral from 0 to pi over 2. Then we got the big root. X dot squared, so that's going to be 9 cos to the 4 now, and sine squared. Plus, and then y dot squared, we get another 9 sine to the 4, and then cos squared. Okay, so we get this mess here. Now, in the previous example, sorry, the one before that, we could just add these two together. Okay, and then we got that single term. Here we can't because it's going to be cos to the 4 for the first one, and then sine to the 4 for the second. So you can't just add them together. However, they both have a common factor. So it will be 9 cos squared sine squared. That's a common factor for both. Does everyone see that? Okay. So 9 sine squared cos squared, common factor, we can take that out. Okay, so again, before you jump ahead to all of your integration stuff, try and simplify first. Okay, so 9 cos squared sine squared, we can factor that out. Okay, and then what's left over? From the first one, we had cos to the 4, so there's a cos squared left over. Sorry, I put theta there, so that's t. Cos squared left over there. And then from the second one, that was a sine to the 4, so there's a sine squared left over. So we end up with this. Now, cos squared plus sine squared, that's just 1, so we can forget that. Root of 9, that's 3, constant, we can just take that out. So it will be 3 integral from 0 to pi over 2. Okay, then we've got the roots of whatever's left over there. Okay, the cos squared plus cos squared times sine squared. Okay. Again, we got this root of something squared, so absolute value there. So this will be 3 integral from 0 to pi over 2, absolute value cos t sine t dt. Okay. Again, before doing u substitution, like u equals sine, du is cos, try and simplify first. Okay, you could do it like that. That would work. But if we've got sine t cos t, this is almost the double angle formula. Right, so sine 2t, this would be 2 sine t cos t. Okay, almost what we got. So again, before you jump to u substitution with u as sine and then du as cos, try to do something like this first. Okay, makes it a little bit simpler. Yeah.
What is this? Cos squared is t plus x squared t.
Oh no, it's times 1. Yeah. So this is just a times 1 there. Yeah, so we can write this as 1/2 sine 2t. So we have 3/2 integral from 0 to pi over 2, absolute value sine 2t dt. Now here we don't have an issue with the absolute value, right? From 0 to pi over 2, this is always positive, so absolute value is not needed. So here we can just write this as 3/2 integral from 0 to pi over 2 sine 2t dt. Okay, so from 0 to pi over 2, it was positive anyway, so the absolute value doesn't really do anything. Okay, now we can just integrate this. There's no absolute value to worry about. So this will be 3/4. Okay, from the dividing by 2 there. Then we have minus cos 2t from 0 to pi over 2. Okay, substituting in, we get a 2. So we get 6/4. Okay, you could leave it like that, or you could write this as 3/2. Okay. Any questions? They're all good. Okay, so for the, there's no homework on this, so you just go through the tutorial questions. I think I saw quite a few of you already did the questions for the tutorial, which is good. The solutions will be posted later today. You can just double check your answers. But in the tutorial from last week, I think it's the same exercise. If you just look at the next page, there's I think it was 10 or so questions on finding the length. Okay, so just go through that. And then also in the other textbook, let me just find that here. The Calculus 2 one. So in the Learn page, there's the Stewart book and there's some extra notes. Calculus 2 here, just have a look. Applications. Arc length over here. So go to Calculus 2 in the Learn page, and then you go down to here, arc length. There's some more questions here. Let's just look here. Here. There's another 4 ones you can go through. Yeah. So Stewart textbook for the tutorial, and then Calculus 2 for the extra work if you need. Okay, but if you can do the stuff from the Stewart textbook, then you're fine. Okay, you're fine for the June test. Okay, so this will be the last thing for the June test. Okay. Then next, so that's it for the lectures. Then next semester, we start again with differential equations. Okay, so if you want to do some holiday work to get ahead, the next thing is differential equations. Okay, so have a look in the Stewart textbook for the differential equation section. It's close to the end of the book. Okay, you'll see there differential equations. Okay, we'll start that after the mid-year break. Okay, any questions on that? All good. Okay, so we'll leave it at